All right, let's take a look at exponential functions. Today we're going to be looking at how to graph exponential functions, how to identify exponential growth and decay, and how to recognize transformations. So exponential growth and decay. Growth is something that increases. Decay is an exponential function that decreases. Some examples of growth: population growth, stock market, antiques, land value, tuition rates, rumors, bacteria, value of art. Some things that decay or decrease in the population of endangered species, population after plague, value of various assets, effects of medication. Exponential change or growth or decay usually has a rate attached to it, so usually a percentage. So anything that's growing or decreasing at a percentage is exponential. Now, how do you determine if something's growth or decay? A function will be exponential growth if the rate, which is the b value, which is the base of the exponent, is larger than 1. If the base is between 0 and 1, then it is decay. Okay, so as long as the a value is positive, then it will represent or be categorized into one of these two categories. If the a value is negative, then it's just referred to as an exponential. It's not growth or decay because it doesn't model anything. Example, y is equal to 0.3 times 2 to the x. The a value is 0.3, the b value is 2, so since it's 2, it's larger than 1, it would be exponential growth. If the a is positive and b is between 0 and 1, it's decay, so y is equal to 4 times 0.2 to the x. A is 4, b is 0.2. 0.2 is between 0 and 1, so that would be decay. Now, the parent function for exponentials is y equals b to the x. That's the parent function. Any other function or any other letter performs a transformation, or any other number would perform a transformation. And this is the standard form with all of the transformations. Y equals a times b to the x minus h plus k. A, h, and k do the same thing as they've done in previous transformations. The k value moves it vertically. The h value moves it horizontally from the parent function. If the a is negative, it reflects it or turns it upside down over the x-axis. And the a also stretches it or compresses it based on the value. If a is larger than 1, then it will stretch it out. And if a is between 0 and 1, then it will compress it. Let's take a quick look at what exponential equations look like, or exponential functions. So right here, this is a growth function, okay? You can see that it rapidly increases from left to right. It also gets very, very close to 0 here. This is called an asymptote. Okay, an asymptote is a line that this graph will never cross. This graph never goes below 0. It gets very close to it, but never crosses it. And this is growth. You can see that it's getting larger. Decay function would simply be the reverse. It's getting smaller. It's getting closer to 0 as we move to the right. Okay, it starts out very large and then gets very, very small. This is decay. Once again, it also has an asymptote at 0. It gets very close to 0, but does not actually cross 0. So our graphs, if it's decay, is going to look something like this, and growth will look something like this, the other direction. All right. We start by graphing the horizontal asymptote, which is determined by the k value. Whatever the k value is, that's the horizontal asymptote. We set up a table, and in the middle of the table, we put the x value that will make the exponent equal to 0. Okay? And then we choose 2 values to the left of that and 2 values to the right of that. We plug in those x values to find their corresponding y values, and then we plot our 5 points to create our graph. So if we look at number 1, y is equal to 1/2 x plus 1. This is exponential decay because the b value, which is 1/2, is between 0 and 1. The horizontal asymptote comes from the k value, so that would be 1. So we'll put that on our graph. It's a horizontal line that goes through 1. And then we need to set up our table. So in the middle of our table is the x value that will make the exponent equal to 0. Well, pretty clear that the only number you have to worry about plugging in, or the only number you have to worry about is the x, so all we have to plug in is 0 if we want to make the exponent equal to 0. Plugging in 0 will make it 0. To the left of 0, we have -1, and to the left of that, we have -2. To the right of 0, we have 1, and to the right of that, we have 2. So we're going to plug these in to create our points and to find all 5 ordered pairs. Then we'll plot them so that we can create our graph. So first I'll plug in -2. Y equals 1/2 to the -2 plus 1. Remember, a negative exponent means that the number should go to the denominator. In the case of a fraction, this negative exponent goes to both of these. So they both go to the opposite place. So instead of 1/2, it becomes 2/1, and then the exponent becomes positive. So this is just 2 squared plus 1, which is 4 plus 1, which is 5. So plugging in -2 gives us the value 5. Next, we'll plug in -1, so 1/2 to the -1 plus 1. Once again, negative exponent, we flip it around because both the numerator and denominator have a negative exponent, so they both go into the opposite place. So this is 2 to the 1 plus 1, which is just 2 plus 1, which is 3. Next, we'll plug in 0, so y equals 1/2 to the 0 plus 1. Anything to the 0 power is 1, so this is 1 plus 1, which is 2. Next, we plug in 1, so 1/2 to the 1 power plus 1. 1/2 to the 1 power is just a half, so a half plus 1. And to make it easy to graph, we'll write this as a decimal, 1.5, 1.5, or 1.5. And lastly, we'll plug in 2, so 1/2 squared plus 1. 1 squared is 1, 2 squared is 4, so this is 1/4 plus 1, and written as a decimal, that's 1.25. All right, we will take all of these and we will graph them, put them on the coordinate plane so that we can create our graph. So -2, 5 right here, -1, 3, 0, 2, 1, 1.5, and 2, 1.25. So we can see, like we figured, it's a decay function, it's decreasing. Gets very close to 1 but doesn't cross it. The domain, -infinity to infinity, because there is no limitation on the x values. Okay, the x goes all the way to the right and all the way to the left. The range, on the other hand, there is a limitation because the farthest down that this graph goes is to 1. It doesn't even cross 1. So since it doesn't cross 1, we use a parentheses, 1 to infinity. We use a parentheses on the 1 to show that 1 is not part of the range. Everything larger than 1 is part of the range, but not 1. Okay, so 1 is not included in the range, so we'll say 1 to infinity. Now we have our graph, we have all the pertinent information. We are finished here. Number 2, we have 2 to the x plus 3 minus 5. This is, of course, exponential growth. because the b value, 2, is larger than 1. The horizontal asymptote comes from the k, which is negative 5. So we'll go ahead and put that on our graph. And then we'll start filling out our table. The middle value of our table should make the exponent 0. Well, the exponent is x plus 3. So in order to make that exponent 0, we'd have to plug in negative 3. All right, the one above that should be to the left, which is negative 4, and then to the left of negative 4 is negative 5. Below, the right of negative 3 is negative 2, and the right of negative 2 is negative 1. We'll plug all of these into the equation. So 2 to the negative 5 plus 3 minus 5. That's 2 to the negative 2 minus 5. So 2 to the negative 2, to make that exponent positive, we'd have to flip it. So 1/2 squared minus 5, which is 1/4 minus 5, which is negative 4.75, if we wrote it as a decimal. All right, now we plug in negative 4, 2 to the negative 4 plus 3 minus 5, just 2 to the negative 1 minus 5. And 2 to the negative 1, we would flip that to make it a positive exponent, so 1/2 minus 5 is negative 4.5. All right, let's plug in negative 3. 2 to the negative 3 plus 3 minus 5. That's 2 to the 0 minus 5, and 2 to the 0 is 1. So 1 minus 5 is negative 4. Plug in negative 2. So 2 to the negative 2 plus 3 minus 5. Just 2 to the 1 minus 5, which is just 2 minus 5, which is negative 3. And then we'll plug in negative 1. 2 to the negative 1 plus 3 minus 5. Just 2 squared minus 5. 4 minus 5, which is negative 1. All right, now we have all of our ordered pairs, and we can create our graph here. Negative 5, negative 4.75 is like right here. Negative 4, negative 4.5 is like right here. Negative 3, negative 4. Negative 2, negative 3. And negative 1, negative 1. So our graph is going to look something like this. All right, we can see its growth, its exponential growth. The domain here, of course, negative infinity to infinity. The range, the farthest down this goes is to negative 5, and it's a parentheses, remember, and it goes up to infinity, so negative 5 to infinity. Parentheses because negative 5, it never actually hits negative 5. And number 3, negative 3 times 1/2 to the x minus 1 plus 4. This is not growth or decay because the a value is negative, which means it's just a regular exponential function. Horizontal asymptote is 4. Keep in mind, since the a value is negative, this is going to be turned upside down. Okay, it is going to be like upside down. To start our table, we need the number in the middle to make the exponent 0, which would be 1, because 1 minus 1 is 0. To the left of 1 is 0, to the left of 0 is negative 1. To the right of 1 is 2, and to the right of 2 is 3. So we're going to plug all of these in and evaluate. So negative 3 times 1/2 to the negative 1 minus 1, so negative 2. Let me just write that down. Negative 1 minus 1. So that's negative 3 times 1/2 to the negative 2 plus 4. So remember, we would flip that. So it's 2 squared plus 4. So that's negative 3 times 4, which is negative 12, and then plus 4, which is negative 8. All right, next we will plug in 0. So negative 3 times 1/2 to the 0 minus 1 plus 4. Negative 3 times 1/2 to the negative 1 plus 4. 1/2 to the negative 1 is, oops, forgot my parentheses, which is 2. That's negative 6 plus 4, which is negative 2. All right, plugging in 0, 1/2 to the 0 minus 1. Oh, I just plugged in 0. I'm plugging in 1. 1 minus 1 plus 4. It's negative 3 times 1/2 to the 0, which is just negative 3, because that's 1. And negative 3 plus 4 is 1. All right, plugging in 2. Negative 3 times 1/2 to the 2 minus 1. So that's negative 3 times 1/2, because 2 minus 1 is 1. Half of negative 3 is negative 1.5. And if we add that to 4, we get 2.5. Lastly, we'll plug in 3. 1/2 to the 3 minus 1. That's 1/2 squared. So if we square the numerator and the denominator, that becomes 1/4. And negative 3 times 1/4 is negative 0.75. Which is 3.25. All right, now we can use these to graph our function. So negative 1, negative 8 down here. 0, negative 2. 1, 1. 2, 2.5. And 3, 3.25. Okay, so we can see that it's upside down. It's not really growth or decay because the a value is negative. Just kind of looks like this. Domain is, of course, negative infinity to infinity. The range is going to be backwards because it's not going to infinity, it's coming up from negative infinity. So it's starting at negative infinity and it's going up to 4, and it doesn't ever cross 4, so we'll keep it just like that, negative infinity to 4. All right, good. It's really just about filling out that table. All right, so on the homework, make sure you write the equation for the horizontal asymptote. Make sure you put the horizontal asymptote on the graph. We're doing 92, numbers 1 and 3 through 6.